We had looked at this function the other day where we were looking at a whole bunch of different inverses and seeing how to undo them. We had taken our x value and we had done 2 to that x value. So in this case it was 7. So 2 to the 7th equals 128. We were trying to figure out what we would do to undo it. So we have a couple ideas where the square root of 128, right? So if you break down 128, that's divisible by 4. So 4 and 32. 32 is 8 and 4. So we have a pair of 4s here, another pair of 2s here, and then a loner 2. So the 4 comes out, the 2 comes out, and then a loner 2, which is 8 root 2, which is not the 7 that we were hoping to get. Okay, well, the square root of 7 doesn't help. So if we try the 7th root, because we had raised it to the 7th power of 128. So again, if we break that down, we've got 4 and 32. 32 is 8 and 4. 4 and 2. These need to be broken down more because we're trying to find groups of 7. So here we have 1, 2, 3, 4, 5, 6, 7 2s. So then when we pull that out, it gives us 2, but we were wanting to get to 7. Okay? So what happens is that you didn't actually know what the inverse function of this was. I just kind of wanted you to think about it and kind of grapple with how would we undo this situation. So what we're going to talk about today is how we undo this kind of function. Now this kind of function is called an exponential function, or it's also our geometric sequences. Okay? So what happens is the inverse of that is what we call a logarithm. So the inverse of an exponential function is called a logarithm. And then we frequently just refer to it as log or logs. Okay? Now, here's our actual definition of what a logarithm is. So it says, if you have b to the x equals a, that's the same thing as log base b of a equals x. So these two things undo each other. Now, it's important that when we say this, it's log base b of a equals x. Okay? So, we can switch between the two different forms using this piece of information. So notice here, the base is with the exponent. Here, this thing, the way that we say it helps us remember that it's a base. So log base, and notice this is what we call a subscript, so it's just below the log. So base b, and then we've got this thing. So this we call the argument. So this thing is the argument. This thing is the base. And equals x, that's our answer. So when we switch it, we have the base, and then the answer is the exponent, and then the argument, the a value, is the answer to the exponential. Okay? So I like to start by identifying the base. So on this one, 3 squared equals 9, the 3 is the base. So I start here. So then when I write my log, I do log base 3. Okay. Now what I do is I notice that the pattern that we have is that it like hops across the equals sign. So our b, and then we have a to x. So b and a are next to each other on the log. So we hopped across the equals sign and then hopped back. So log base 3, hop over, of 9, hop back to the exponent equals 2. Okay. So your answer to a log is an exponent. Answer to a log is an exponent. So in our example over here, we would really want this to be log base 2 of x, and that would get us to this number here. So if we did log base 2 of 128, that would get us to our 7. Okay. If I try this one, remember the base is the thing that has the exponent. So the 25 is the thing with the power. So the base is 25. So I'm going to start with the 25. I'm going to do log base 25 of, hop to the other side, and then hop back equals 1/2. Okay. So pause the video here and try the rest of them, switching to a log form. Now remember, it's important that you pause the video and you try it. Things are easier when someone is showing you how to do them as opposed to you trying them by yourself. So it's important to try them by yourself and then check with the rest of the video. Okay? So that means you should have all of these done now. Okay? So here, our base is the 2. So it's going to be log base 2 of, hop to the other side, 32, hop back equals 5. Okay? Here, our base is the 5, so we're going to do log base 5, hop to the other side of 162, hop back equals x. Okay. Now, I am going to show you one other way that you can think about switching. Because logs and exponentials are inverses of each other, you could also take the log of both sides. So for example, if we had done x squared equals 4, remember we solved this by taking the square root of both sides. Well, you can do that similarly. If you want to undo the exponential, you could take the log of both sides. So if I take the log of both sides, I do log base 8, it will still be whatever the base is. And then similarly with square roots that go on the left side, the log would have to go on the left side. So log base 8 of 8 to the b, log base 8 of 279. Well, log base 8 of 8 to a power, these are inverses, so they undo each other. So we're left with b equals log base 8 of 279. So that's a second option that you have, that you could switch between the two of them. So if we try that on the next one, 4 to the 6.3, I still need to identify what my base is. So my base is 4 because it's the thing with the exponent. So I'm going to do log base 4 of both sides. Okay. So log base 4 of 4 to a power, the log base 4 of 4, those undo each other, so we get 6.3 equals log base 4 of x. Okay. I don't care which way you do it, I just need you to do it. Okay. Now, there are two bases that we have special ways to write the logs. One of the bases is base 10. Our numbering system is in base 10, so that's why we have a different way to notate it. And then we also have one with a number that you probably have not heard of before. So this number is e. Okay. So e is like our pi value. Pi is an irrational number because it goes on for forever, the decimal does, and doesn't repeat. Same thing with e. E is an irrational number. It goes on for forever. Now the e, it's the rate of growth of anything that's continually growing all the time. Okay, which seems weird. So this number actually happens in nature, which is bizarre and weird, but that's what happens. Okay. So for our intents and purposes, we're thinking e is 2.7, right? Because we're not going to be specific enough that we need to go past this. But we use e to write that number. So instead of writing 2.71828182845, right? It kind of looks like it's going to repeat for a minute and then it starts to vary. Okay. So instead of writing that out every time, we just assigned a letter to it. So we assigned the letter e. Okay. So with base 10, because our numbering system is in base 10, mathematicians are inherently lazy with their writing. We like to shortcut things, which is why when we do the square root, we don't write the index of 2, or why when we have a 1 out in front, we drop that, or a 1 with a power, we drop that as well. Okay. So same kind of thing with log. Since we are in base 10, and that's our numbering system, anything log base 10, we just opted to not write the base of 10 because we used it all the time. Okay. So for example, if we have 10 to the 5th equals 100,000, then I would write this in log form, log of 100,000 equals 5. So notice I don't have my base 10. So if there's no base, it's an unsaid base 10. Okay. Now, with our base e, when we switch it to log form, we call it the natural log. Okay? And we use ln to abbreviate, which seems backwards because it's natural log, but I'm pretty sure it was French, the French mathematician who did this originally. In their grammar, they do log natural, so that's why it's ln instead of nl. Okay? So our natural log, we abbreviate as ln. So if I have ln of 204, that means that this is really e to x equals 204. Okay? So let me give you a few examples. So here, again, you could do log base 10 on both sides. I'm writing the 10 so that I can visually see. And then when I cancel them, I'm going to drop for my final answer that I don't need this base here. You could do it the other way where you say, okay, well, this is base 10. I hop to the other side. So log base 10, I didn't write that right. Log base 10 of hop to the other side, 100 equals 2. But we just shortcut that and say log 100 equals 2. Okay. We can do our natural log similarly. So this is e, meaning 2.71828182845 continuing on for forever. Okay. So that's our base. So I'm going to do log base e. Okay. Anytime you see log base e, you should think, oh, I need to switch that to natural log. So our natural log of hop to the other side of x, hop back, equals 4.7. Okay. So, again, I want you to pause the video and try these ones that are left over and then check them. Again, it's important to be trying on your own. Okay, so here you should get log of 1056792 equals x. I don't have that base here because it's an unsaid 10. This one would be log p equals 5.6. Okay. Here, this would be natural log of p equals 8.9. Okay. And here, you can also do the same thing when you are taking the log of both sides, but this would be the natural log of both sides. So the natural log of e, those undo each other, so you got x equals the natural log of 5679. And that's how you switch from an exponential to a log, including our special bases that we have.